Hi. Chemical bonding is a force of attractions. When in an oxygen and hydrogen are coming together, there will be forces of attraction as well as repulsion. Attractive forces as well as repulsive forces. When the force of attraction and force of repulsion are equal and the force of attraction overcomes the force of repulsion, then a bond is formed. Then there exists a bond. That bond is called as chemical bond. During a chemical reaction, atoms comes closer and are held together by force of attraction to form a molecules. These force of attraction which holds together hydrogen and oxygen atoms in the case of water molecule are likewise is called as chemical bond. Little more explanation about chemical bonding is nothing but the attractive forces that holds two or more atoms are oppositely charged ions together are different species. It may be ions, it may be sharing of electrons. We shall again further discuss what exactly how many types of chemical bonds are there and etc. So in a chemical bond, the attractive forces are held together by means of an oppositely charged ions or by sharing of electrons and XYZ. That mechanism which holds together is called as a chemical bond. Chemical bond is nothing but the force of attraction which holds two or more atoms or oppositely charged ions or different chemical species together is called as a chemical bond. Then comes what exactly the forces of attraction and the forces of repulsion. The attractive forces are due to the positive and negative positive ions. For example, if you consider here, atom consists of positive sphere which contains protons and neutrons, and electrons are the negatively charged species which will be rotating around. Similarly, when one more positive atom comes, when one more ion comes here, center is positive, neutrons are there, electrons are there. Electron, there will be repulsion because of negative and negative charges, it would be repulsing each other. And this electron, when it comes here in the revolution, when it comes here, this electron is negative and this is positive. So this positive and negative gets attraction. So there are forces of attraction here and there are the forces of repulsion. When the attractive forces are more, then we can consider it as bond formation takes place. Attractive forces, repulsive forces and etc. So why actually the question may come, why there should be an attractive forces, why there should be repulsive forces, and why they need to be formation of a bond. See, in nature, what are the stable elements? We all know that stable elements are noble gases, or we call it as real gases, or inert gases, etc. Inert itself means stable. If you consider and if you see these electronic configurations of noble gases, helium electronic configuration is 2, neon electronic configuration is 2,8. If you consider according to Bohr's theory, implementation of electrons 2,8. Argon 2,8,8. Similarly, krypton 2,8,8. These are shells: first shell, second shell, third shell, fourth shell, fifth shell. In all these cases, except in this case of helium, helium is 2. But whereas if you see neon, outermost electronic configuration is 8. If you see argon, the outermost electronic configuration is 8. Similarly, krypton, similarly xenon, similarly radon. This all electron contains 8 electrons in the outermost orbit, whereas helium contains 2 electrons in the outermost orbit. As observing all these noble gases, we can say that the elements which has 8 electrons in the outermost configuration, if you not consider if you don't consider helium, because helium is different again, helium is also inert gas, but it is the only case where it will be having 2 electrons in the outermost state. In the all experimentations, just helium case, it is having duplet configuration. 8 electrons in the outermost state, it is called as octet configuration and duplet configuration. So according to different laws, valency electron, the outermost shell is called as valency electron. Helium has 2 electrons in the outermost electronic configuration, which is called as duplet electronic configuration. Neon, argon, krypton, xenon and radon are the elements which has 8 electrons in the outermost state. That means 8 electrons in the outermost state is considered as stable electronic configuration, which is nothing but octet configuration. Just octet. So all the elements in the nature will try to acquire the octet configuration. So any element in the nature, we will try to acquire octet configuration. Where this octet configuration is only in the last shell. That shell is called as Valency shell. What is valency? Valency is the number of electron presence in the outermost shell. What is outermost shell? Outermost shell is valency shell. So these just now we have seen in all inert gases. This, for example, this if you consider it as carbon, carbon contains 6 protons, 6 neutrons and 6 electrons. First orbit contains 2 electrons, outermost orbit contains 4 electrons. So in this case, what is the, how many electrons it requires for the stability? It requires 4 more electrons, or 8 electrons means 8 minus 4, it is 4 already available, so 4 more are required. For attaining of stability, valency electron should be 8, and this is called as Koszul-Lewis theory. It tells that the outermost energy level in an atom is known as valency shell, and the electron present is called as valency electrons. These valency electrons should be 8, and it is called as octet rule. Octet rule is nothing but an atom or an element which possesses 8 electrons in the outermost orbit is considered as stable electronic configuration. Children, 3 things are important here: valency, valency shell, valency electrons, octet rule. Octet rule is nothing but octet means 8. So 8 electrons present in the outermost orbit is called as octet rule. 8 electrons in the outermost orbit. What is outermost orbit? Outermost orbit is nothing but valency orbit. The number of electrons present in the valency orbit are called as valency electrons. Valency electrons are nothing but the number of electrons present in the outermost orbit. Lewis has given structures for these writing of notations, simple notations. For example, hydrogen. If you consider hydrogen, how it can be written? Hydrogen can be written as 1. Hydrogen atomic number is 1, and he represented that 1 electron which is present by this structure. This is called as Lewis structures. Hydrogen 1, helium, if you consider 2 electrons are present, 2 structures, 2 dots. If you consider lithium, there are 3 electrons present, 1, 2 and 3 electrons. Similarly, if you consider beryllium, 4 electrons, 1, 2, 3, 4. Boron, 5 electrons, 1, 2, 3, 4 and 5 electrons. Carbon, 6 electrons. See, now the electrons are different. Electrons present in the outermost orbit is different. Hydrogen has 1 electron in the outermost orbit. Helium, 2 electrons, 2 outermost orbit. Here if you consider from lithium onwards, the 2 electrons will go into first orbit. Similarly, beryllium, 2 electrons will go into first orbit. Boron, 2 electrons will go into first orbit. Second orbit, nothing but outermost orbit. So the electron present in the outermost orbit are important for us. If you write electronic configuration of lithium also, lithium atomic number is 3, electronic configuration is 2, 1. Similarly, beryllium electronic configuration is, atomic number is 4, electronic configuration is 2, 2. That means this is a valency shell. In the valency shell, outermost electrons are 1 and 2 in the case of lithium and beryllium. Similarly, boron, if you consider, atomic number is 5, 2, 3. Carbon, atomic number is 6, 2, 4. So these 4, 3, 2, 1 are called as valency electrons. According to Lewis structures, dots represents only outermost electrons. Hydrogen is 1, lithium is 1. You need not confuse that lithium atomic number is 3. Why we are not writing? We are writing only outermost electrons. The number of electrons present in the outermost orbit are called as valency electrons. Hydrogen symbol is this, lithium is this, beryllium. It's not like specifying that beryllium we are keeping here only 2 dots. 1 dot can be kept here, 1 dot can be here. Carbon 6 we can write like this. Or if you want to write 1 here and 1 here is also okay, no problem. So this is all Lewis structures. We shall see a few questions related to that. How far you understood about this valency, outermost electronic configuration or chemical bond. The force of attraction between the atoms or ions is called as, what is that called as? It is nothing but chemical bond. The force of attraction between atoms or ions is called as chemical bond. If 2 electrons are present in the first shell, it is called, just now we have discussed about duplet electronic configuration and octet electronic configuration. The finally number of electrons which can be accommodated in first shell is 2 electrons. So the number of electrons when present, 2 electrons are present in first shell, it is called as duplet electronic configuration. We shall see few more questions related to this. If 8 electrons present in the valency shell, it is called as, yeah right, it is octet electronic configuration. Octet. Octet is nothing but 8 electrons present in the valency shell, not all together. It should be valency electrons only. The combining capacity of an element is called as valency, which valency is nothing but combining capacity. So the element, how many outermost electrons are there, and accordingly how it would be going on, is called as combining capacity. Atoms with 8 electrons in the outermost shell are chemically. Just now we have discussed about octet electronic configuration, valency electrons. If it has 8 electrons in the outermost orbit, then what it is called as? Then that kind of atoms or ions or molecules would be more stable. The stability will be more. The symbol of an element surrounded by the valency electrons of its atoms, represented in the form of dots around it, it is known as. What it is known as? Just now we were writing about hydrogen, symbol of element surrounded by dot. Carbon, dot surrounded by dot. What are these symbols known as? These symbols are known as exactly Lewis symbols. These symbols are known as Lewis symbols. Lewis proposed this kind of symbols, so these are known as Lewis symbols. The dots in Lewis represents the number of outermost electrons present in that. The electronic configuration of sodium ion is, the electronic configuration of sodium ion means sodium atom, you know atomic number of sodium is 11. It has 2, 8, 1 electronic configuration. Sodium ion Na with the loss of 1 electron. 1 electron is present in the outermost shell. If you remove this electron, then it would be 2, 8. So electronic configuration of sodium would be 2, 8. So sodium ion is 2, 8. Which of the following elements do not form a molecule? See, MCT means multiple correct type. There may be questions and there are answers. There are more than one answers in this. Which of the following elements do not form a molecule? Which kind of elements are not required to form a molecule? The elements which are stable by itself. What are that elements? Inert gases or the noble gases are the elements which are stable by itself. Example, the elements are helium, argon are the elements which are inert gases or the real gases. This is matrix matching type again. This is multiple correct type and this is matrix matching type. This column A is ABCD, column 2 is PQRST. Sodium, what it is? Sodium is a sodium formed ion, therefore it is unstable. Sodium formed ion, it is an unstable. Duplet electronic configuration means, duplet or octet electronic configuration means stable electronic configuration. So answer option of B is Q. What about xenon and argon? These two are also elements of stability, therefore these two are also stable and inactive. In these xenon and argon, is there any electronic configuration matching? Xenon atomic number is 54, electronic configuration matching does not exist. Argon atomic number is 18, electronic configuration is 2, 8, 18 electronic configuration. So just once again, if you recapitulate what are the things, chemical bond is nothing but the force of attraction which holds atoms or ions together. That particular bond which holds together is called as a chemical bond. In chemical bonding in initial stages, what are things which we require to know? Valency electrons, octet rule, Lewis dot structure. What is valency? The number of electrons present in the valency shell is called as valency. That means 8 electrons, if it is present, it is called as octet configuration and it is considered as more stable, except in the case of helium. If it is 2 electrons, it is also considered as stable. It is called as duplet electronic configuration. What is valency shell? The outermost shell in an atom is called as valency shell. Children, as we were discussing the stability, these elements, inert gases, are called as stable electronic elements. Helium, neon, argon, krypton, xenon and radon. These are the elements which are stable because these are also situated towards the right side of a periodic table. All these elements are stable. These are called as elements which are reactive, and these are metals. These are D block elements, these are F block elements. The stable elements are these elements, and it is nothing but real gases. See, if you see this, just whatever we were discussing, once again we shall discuss. You see this. Helium. Center of atom contains two protons and 2 neutrons. Outermost 2 electrons are present. So this is called as duplet electronic configuration. Similarly, neon. Valency shell, inner shell. Inner shell has 2 electrons. Neon electronic configuration is 2, 8. It has 8 electrons in the outermost shell. Now argon. What does argon consist of? 2, 8, 8. It means 2 electrons, 8 electrons and 8 electrons. In these cases, all these cases, just as we are telling it as stable, neon, argon, krypton, xenon and radon. I am removing radon. Now you can see helium, neon, argon, krypton, xenon. These elements has 2 electrons in the outermost and it is stable. This is called as duplet electronic configuration. This is outermost, which has K shell and L shell. K shell has 2 electrons, L shell has 8 electrons. 2 electrons in the outermost shell is called as 8 electrons in the outermost shell is called as stable electronic configuration. Similarly, krypton has 8 electrons in the outermost shell. Similarly, xenon has 8 electrons. Similarly, argon has 8 electrons. This is all electronic configuration representation of shells. First shell, K shell, L shell, L, M, N. Outermost, you can see outermost. So these elements are in the periodic table are considered as most stable elements. Why they are considered as stable elements? Because they has 8 electrons in the outermost. They has 8 electrons in the outermost. Even argon has 8 electrons in the outermost state. Similarly, krypton has 8 electrons in the outermost. So outermost state, it will be having 8 electronic configuration. So the stability of the elements are nothing but they consist of 8 electrons in the outermost orbit. That was a further little more explanation related to stability of neon, argon, krypton, xenon and radon are stable gases. Further, what kind of chemical bonds would be there? Ionic bond, covalent bond, how the covalent bond is formed, how the ionic bond is formed, how the metallic bond is formed. Ionic bond is also called as different names. Covalent bond is formed with different names. This all we shall discuss in the next class, and you just go through all the things, just go through elements and atoms and how exactly are there. You can have different examples, water molecules, sulfur dioxide, etc., like molecules and valency symbols and etc.